Alrighty, welcome to day 4 of 1 of Adventure Code 2022. I am about 2 hours late to do today, as well as I was on day 2, so we're going to kind of skip the intro and just get right into today's problem and get started. Space needs to be cleared before the last supplies can be unloaded from the ships, so several elves have been assigned to the job of cleaning up the sections of camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare the section assignments with each other, they've noticed that many of the assignments overlap. To try and quickly find overlaps and reduce duplicate efforts, the elves pair up and make a big list of section assignments for each pair, your puzzle input. For example, consider the following list of section inputs. The first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 through 4. The second elf was assigned sections 6 through 8. The elves in the second pair, we should assign 2 sections. The elves in the third pair, we should assign 2 sections. One got sections 5, 6, and 7, while the other got 7, 8, and 9. This example list uses single-digit section IDs to make it easier to draw your actual list by containing larger numbers. Visually, these pairs look like this, right? Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained by 4 through 6. Oh, sorry. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning the sections of the other. Okay. How many assignment pairs does one range fully contain the other? This one's actually not too bad. Oops, I tried to save the full file. This one's actually not too bad. So what we're gonna do here is we're gonna go just call it contains, I guess. Whoops. And of course we're gonna do a for loop to go over all of the lines of our inputs. S and input, there we go. And the first thing we're gonna do is we're gonna break up our inputs into the two parts, which simply just be S dot split on a comma, because there's a comma separating them, correct? And some of them have the two parts, so we need to know if one section, like right here, the very first inputs, is contained within the other. The easiest way to do this is going to be let's actually do another string parts. This is going to be section 1 parts is going to be equal to parts 0 split on the dash, and the section 2 parts is going to be 1 splitting on the dash. And so we can do int is going to be section 1 lower is going to be equal to section 1 parts 0, and we need to parse the integer. Okay. And section 1 upper is going to be just this. Copy this. Now we get section 2. And now we can actually test if it's within easily, because it's either going to be if section 1 lower is less than or equal to section 2 lower, and section 1 upper is greater than or equal to section 2 upper. This means that the second section is fully within, so we can do contains plus plus. Otherwise, if we flip these around, if section 1 lower is fully within like that, now it also contains here, and that should be all we need for this. It'd be nice if I could spell contains correctly. Right. If I could spell contains, that'd be nice. And then I think we should be able to do lab contains, and I think that's all we need. 498. There we go. Nice and easy. I have a feeling, though, me doing that the hacky way is going to screw me over in this part, though. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. An example above, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. Oh, actually, this isn't too bad. And we'll just do a second one here called overlap, which is actually not too bad. It is actually not too bad. So what we need to do now is we just need to know if same thing. No. If section 1 lower, actually, if section 1 upper is less than or equal to section 2 lower, or flip this around, section 1 lower is greater than or equal to section 2 upper. I believe that's all we need to know for an overlap. I think. That's wrong because there should be more. Section 1 upper. Is greater than no. It's still this, but it should be an or, right? If they overlap at all, that means the lower is within here, or the upper is within here. So it's actually be a little bit more. So section 2 lower is, if section 2 lower is less than or equal to, sorry, if it's greater than or equal to lower, and then, or it is, no, if it's greater than or equal to that and it's less than or equal to that, and then we need to do another and, another and, no, sorry, then we do an or, right, okay. I think about that for a second. This with an or, if the upper is greater than lower, and that. There we go. And now we can just take this, plop it in here, and we just flip it around. One, two, 2, 1, 2, 1. Right? Hey, there we go. I had to flip around. Yeah, because it's either, okay, that one wasn't too bad at all. Wow, that was done really quickly. That was done really. This was one of the easier days. I'm gonna guarantee the leaderboard for today was really quick. I don't think it doesn't say times. I wish it said how long it was up. Today must have probably been one of the easier days. All right, I don't think I'm gonna need to clean this. I don't think I'm going to need to clean this code up anymore. Yeah, I mean, in theory, this is basically as kind of logically as good as it's going to get. I'm sure you could kind of reduce this down more, but there's really not any reason to. This is kind of like the readability. So, with that being said, then I'm just gonna skip over clean this up, and we're just gonna jump right into the kind of the solving explanation. So, today's problem, if I bring it back up and don't go to my my desktop. Today's problem is we are given elves and we're given some ID numbers or sections they cover that for cleaning. Each row has 2 elves on it, and each elf is assigned a range of sections that are then separated by commas for each elf. So this example here, this first elf is in charge of sections 2 through 4, with this one in charge of 6 through 8, this one 2 to 3, with another one being 4 through 5, so on and so forth. And for part 1, it's just asking us figure out how many of these lines, the 2 elves on those lines, have complete overlap with one or the other. So one of them is fully contained, one range is fully contained within the range of the other. Doing that is actually really simple. First, we just parse it out. That way we can get the first elf's upper and lower bound, and also the second elf's upper and lower bound. And then we can just test if the, let's go here. If the second elf's lower is greater than the first elf's lower, greater than or equal to the first elf's lower, and their upper is less than or equal to the upper of the first elf, that means that the second range is fully within, because let's see, it's number, where's the example here? Here we go. In example, 3 is greater than 2, greater than or equal to 2, and 7 is less than or equal to 8. That means that the lower bound on this one is within or is greater than this one, but its upper bound is lower than the upper bound on this one. That means it's fully contained. Its range is full inside. Hopefully that makes sense. But that's all we're going to do from there, but that only checks one side of it. We can also have it to be where the first range is within the second range. So basically you just take that logic, flip it around for the other range, and do that logic check there. That gives you part 1. Part 2 is taking that, but instead of checking if it's fully contained or fully within, it just needs to overlap at all. Checking for overlap, again, it's not hard. I feel like this logic might be a little bit verbose. I'm used to checking like rectangle overlap. I feel like with bring in like overlap there, it might be easier, but either way, basically it's the exact same thing here, but instead of checking it's fully within, we only care about that one of the bounds is within the range. So if the lower bound is basically within the range of the other one, then it means the overlap. So the lower bound is within range, or the upper bound is within range, and there is some overlap because, again, one of the numbers is in there, so you got to have some sort of overlap. And that's all we care about. So again, check for the overlap on the second one into the first, or check for the overlap of the first one into the second. This might be a little bit redundant. I don't know. I'm curious. Is that redundant? I don't think so. No, it's not. But that's it. That's a problem for today. It's not nothing too complex. It's just understanding the math of how ranges fully interact and how your bounds kind of determine whether or not the logic there contains or doesn't contain. So overall, day 4, not too hard at all. Hopefully you guys enjoyed. I'll see you guys tomorrow for day 5. Peace out.